So today we look at section 2.8, which deals with what's called linear inequalities. So at the beginning of chapter 2, the first three sections, we dealt with equalities. And an equality, basically just an equation. So an equality has an equal sign. An inequality, on the other hand, could be any of these things. It could be a less than, it could be a less than or equal to, it could be a greater than, and it could be greater than or equal to. So when we're talking about inequalities, we're talking about these four things. And we're going to basically be solving inequalities very much like we solved equalities, with just one exception. But also we have different ways of stating the solutions to these. So as an example, let's say we have this equation 2x equals 6. And if we're solving this equation, we know we would go ahead, we divide by 2 on each side, and we would get x equals 3. And if you look at this, that means there is just one solution to the equation, just one solution. There's only one number that makes this original equation work. Okay, so if instead we have an inequality, like maybe 2x is less than 6, and then we go about it the same way as before, we try to isolate the x, so we divide each side by 2, and we get x is less than 3. Well, now if you think, how many numbers are less than 3? Well, an infinite number of them, right? So this has infinitely many solutions. Right? There's infinitely many numbers that are less than 3, and if you plug any of them into the original inequality, it will make it work. So another thing that we have to be able to do is, whereas here there's only one way to write the solution, over here there's a lot of different ways to write the solution. So if you write this solution to this inequality like this, it's called just an inequality. So I'm going to write this a few ways. So you could say the solution is x is less than 3. That's the inequality. That's how you state the solution as an inequality. Another way you could do this is you could use a number line. And there are a couple different ways to make a number line. So I'll do it both ways, and you can use whichever way, whichever way you're comfortable with. So usually I just put a 0 here just to kind of place the number line here. So we've got a 0 here. And many of you learned this technique where if you want a number x, like we want to show all the numbers that are less than 3 on the number line. And many of you learned this technique where you put a open dot at the 3. And then we're basically saying, well, 2 is a solution, right? 1 is a solution, 0, 1/2. All of these numbers, in fact, on the number line to the left of 3 are solutions, so that what we do is we shade in that part of the line. So we're basically saying, when we shade like that, all these numbers are solutions all the way. Think where this goes in the negative direction, it goes to negative infinity. All those numbers that you plug in here will be a solution. So we do it this way with this open circle. And the open circle means that 3 is not included. This says x is less than 3. If it said x is less than or equal to 3, then we'd have a closed-in circle. So the book does this a little bit differently. And for me, it doesn't matter which way you do it. So what the book does here is it will use a parenthesis here on the 3 and then shade all this in. We definitely need to shade this in because we need to show that there's a difference here as opposed to here, right? Or here as opposed to here. We're saying all of these numbers work. Any number you find here works, all the way to negative infinity. So the book when you look on the number line solution, they will put a parenthesis here instead of an open dot. But you can use either one of those. Doesn't matter to me. So this is the solution using a number line. Okay, another way you can use the solution is what's called set builder notation, which basically is taking this inequality and wrapping it up in a fancy package. So the way you use the set builder notation is you say x such that, and this vertical line right here in math, this means such that. This little line in math means such that. And then you write your inequality, x less than 3. And we use these fancy brackets like you would if it were a set. So some of you took high school geometry and you'd have a set. You'd use these set notation and you put the elements in the set. You'd list them. So it's similar to that, but we have x such that x is less than 3. It means that the solution set consists of all x's such that x is less than 3. It's basically just this wrapped up in fancy packaging. And this is called set builder notation. Okay, so beyond this class, you typically see a solution as an inequality or as this fourth way that we're going to look at is interval notation. Beyond 098, you don't really see number line solutions too much. And normally beyond 098, you'll see an inequality without all of this fancy packaging. But so there's really, 4 different ways to state this. Whereas remember with an equation, we just have one, x equals 3. But here, we've got a lot of different ways. So let's look at the fourth way, which is probably the most important way because this is the way you'll see it when you get out of this class and move on into higher math. You typically use what's called interval notation. And interval notation is a way where you put a couple of numbers here and the smallest one always goes on the left. So you can kind of think of it as a number line. Numbers to the left are always smaller than numbers to their right. So to show the solution with an interval, we say, okay, where do we start? Well, this goes all the way to negative infinity. So we are actually starting at negative infinity. We go up to 3. So with interval notation, you either use parentheses or brackets. So we use a parenthesis on negative infinity because you always use a parenthesis on infinity, any kind of infinity, negative infinity or positive infinity, because a parenthesis means you don't really get there. And with infinities, we never really get there. And then here with the 3, we use a parenthesis on the 3 because the 3 is not included in the solution. It says x is less than 3. If it said x is less than or equal to 3, well, we mentioned we fill in this dot. Here we would have a bracket. And same thing here, this would be a bracket. So we'll see that as you do more of these, when there's an equal to here, so if it had said x is less than or equal to 3, then 3 would be included in the solution. We put a bracket here. A parenthesis means 3 is not part of the solution. A bracket means 3 is. So this means you can get infinitely close to 3, but you can't quite get there. So 2.99999, that works, but not 3. That's what the parenthesis is for. For number 16, it's on page 176, they give us this inequality here. This is called a compound inequality because there's 2 inequality symbols. It's a compound inequality. And it basically wants us to graph the solution set of this inequality and then also use interval notation. So to graph this one, we'll do it 2 different ways again, and it doesn't matter to me which way you choose to do it. We have negative 3 and a 3, and I'll write this again so we can do it twice. Negative 3 and a 3. Okay, so the way many of us were originally taught was this. So since we want t to be greater than or equal to negative 3, and at the same time we want t to be less than 3, that means t could be 0, right? 0 works. 0 is greater than or equal to negative 3 and also less than 3. Or 1, or negative 2. So the way we were taught is you have an open dot on the 3 and then a closed dot on the negative 3. Because the closed dot means that t could be negative 3. And that's what this says. T greater than or equal to, right? Greater than or equal to negative 3. So that's filled in. Here it's open because just t is less than 3. We also have to show that all of these points are solutions. So we can't leave it like this. We need to fill this in also. So we need to make it clear that this part of the line is definitely different from this part or that part, because this is a solution. Every point on this line between these numbers is a solution to this inequality. So you can do it this way, or you can do the book's way. And the book would have a parenthesis on the 3, a parenthesis, and they'd have a bracket on the negative 3. And then these would all be filled in. So all we need to know is that mathematically this bracket is the same as a filled in dot. That bracket means that there's an equal to part. T is greater than or equal to negative 3. So if you show it this way, you fill in the dot. This way you bracket. A bracket means you include this point negative 3. Over here we've got a parenthesis or an open dot. These both mean that we don't include the 3. So then if you write this in interval notation, we always have the smallest number on the left. It's got to be the smallest number on the left, largest number on the right. Well, it's just like a number line. If you have a number line, the number on the right is always bigger than the one on the left. So that's why we just write negative 3, comma 3. And with interval notation, we use a parenthesis and a bracket. So interval notation works just like the notation here that our book uses for the number line. So again, this is the solution using a number line. This is the solution using what's called interval notation. And of the two, this is the more important one because this is what you'll see when you get out of 098. If you go into more algebra-based or calculus-based math, you'll see this. So here is one for you guys to try, number 18. So what you should do with this one, I'll write it down here and just try it out. Press pause. Try it out and then come on back and see how you did. And it's the same. Same kind of thing. We've got this. They give us the solution. Now, if you look at this one, this solution is given in set builder notation. They want us to give the solution using a graph and also using interval notation. So go ahead, try it. Press pause, try it, and then come on back. Okay, so with this one, if you use a graph, and I'll do it twice again because, like I said, there's a couple ways you can do this. So I'm just going to label 1/2 and 4, just so we have these here, 1/2 and 4, which means that 0 is like right around here, right? Here's 0, 1/2, and 4, so 0 would be over here. Well, x, it says, is greater than 1/2, but less than or equal to 4. So the old way of doing this, we would go greater than 1/2, less than or equal to 4, so it's filled in on the 4. And all these points in between also work. With the newer way of doing it, the way the book does it, we put a bracket on the 4 because 4 is included. We use a parenthesis on the 1/2 because 1/2 is not included. And then we fill all this in. So that's using a number line. Using interval notation, put the smallest number, comma, largest number. It's always smallest number on the left. And then we would have a bracket on the 4 and a parenthesis on the 1/2. So that should hopefully get you started on those kind of questions. There's a lot of the other questions are going to have us solve inequalities. And solving inequalities is just like solving equations with one exception. So if you remember, we had that handout for solving linear equations. The handout works here too. Okay, so when we're solving these inequalities, it's just like solving equations with one exception, just one. That one exception is we have to do something different when we multiply or divide by a negative. Now, we're really never going to multiply by a negative, so really the only thing we need to be aware of is divide by a negative. And you have to keep in mind, it's not dividing and it's not the negative. You can subtract things just when you divide by a negative. Only when those two things happen, dividing and also by a negative. When that happens, we have to reverse the direction of the inequality. Now you might be thinking, why would we have to do that? That's an excellent question. So let's take a look. So if you take a look at the number line here, and you look at this inequality, 4 is greater than 3, which we know. And all of us learned at one time probably about the alligator, right? The alligator eats the bigger number, or maybe Pac-Man eats the bigger number. But so the way this is written is it opens at the 4, so 4 is greater than 3. And if you look on a number line, you see 4 is to the right of 3. So I'm going to make a note of that. 4 is to the right of 3. So that means 4 is bigger. Numbers to the right are always bigger than numbers to the left when you have a number line here. But you notice that as you go down to 0, because of the symmetry here, it changes. So let's say I take that 4 is greater than 3 and apply what we learned about equations. Even though this is an inequality, we learned with equations we can do anything we want here as long as we do exactly the same thing to the other side. So let's just say I divide this by a -1 and this by a -1. And then we know that negative divided by positive is going to be negative. So that gives us -4 and -3. But now if you look up here, -3 is to the right of -4. Right? So over here, -3 is to the right of -4. And so what that means is that we could say -4 is less than -3. So basically what happens is when we divide by a negative, we have to reverse the direction. Otherwise it's going to be wrong, right? Because see, 4 is to the right of 3, 4 is greater than 3, but over here, -3 is to the right of -4, so -3 is greater than -4, so it opens at the -3. That's the bigger number. So the only thing we have to keep in mind when we're working with inequalities is that when you divide by a negative, we have to reverse the direction of this inequality sign. Everything else is going to be just like solving equations. So just remember the one exception. Treat an inequality like an equation as you're solving it, but if you divide by a negative, we reverse the direction of the sign. And then, of course, there's different ways to state the solution. So let's take a look at some of these and see how we do. So problem number 51, they give us this inequality, right? It's an inequality. It's not an equation. It's an inequality, but we're going to treat it just like an equation unless we divide by negative. They want us to answer this using set builder notation and interval notation. So I'm going to go through the same steps we did at the beginning of chapter 2 when we were solving linear equations. So I'm going to look through the steps. It's going to say distribute if necessary, which it's not. There's no distributive property here. Then we look for fractions, and there are none. So then it says get all the variable terms on one side of the equation. Well, it's inequality, but works the same way. So we've got a 2q and a 3q. So what I'm going to do, I'm just going to go minus 2q here, minus 2q here. 3q minus 2q is just q. So I have q minus 7 is greater than 3. So then all the variable terms are on the left side of the equation, which means I have to get all the number terms, numbers without variables, on the right side. So I'm going to have to add a 7 here to get rid of that 7. And that will give us q is greater than 10. So this is our answer, but they want the answer in set builder notation. Well, that's easy. Set builder notation is just a fancy version of this, right? It's just this, just fancy. So set builder notation, I make my fancy set symbol, write q such that, and then just write down the answer. Q such that q is greater than 10. Okay, so that's set builder notation. Then they also want interval notation. Well, if you think about what we've got, q, we want all the numbers q that are greater than 10. Also with this notation, these always have to be the same, right? We're saying we want all the numbers q such that q is greater than 10. Meaning all the real numbers q such that q is greater than 10. So to make your interval notation, sometimes if you're new, it helps to make a quick number line. So I'm just going to sketch this number line here. We've got 0, we've got a 10, and we want all the numbers greater than 10. So we'd have like this open dot here and all the numbers going over here. Just remember what this means. That means that out here is an infinity, right? We're going to infinity. So in other words, what's bigger than 10? Well, a million is, right? A billion. And we could basically pick any number all the way out to infinity. So the way we could write this in interval notation is we start at 10 and we go to infinity. And infinities always get parentheses. Because if you put a bracket here, that means you actually reached infinity. Right? So you would actually be able to say, oh, I know how big it is. I saw it. And we don't ever get to infinity, right? It's not a number. It's like it's a concept. So infinities always get parentheses. Positive infinity is always going to be on this right side. Negative infinity is always going to be over here on the left, because there's no number smaller than negative infinity, and there's no number larger than positive infinity. And then the 10, because it's strictly greater than, the 10 is a parenthesis also. Now I can tell you that there's a little memory hook that students use here. So once we get here, here's a memory hook you can use. Doesn't this look kind of like an arrow pointing to the right? If you think on the number line, far to the right is infinity. Because sometimes students will get confused, like, is it a negative infinity to 10? So think of it like this. It's pointing to the right in the number line. As long as your variable is listed first, you can always do this. It's pointing to the right. Way off to the right is infinity. So you could do it this way. Just a memory hook. Otherwise, sometimes students like to just quick make a number line so you can kind of see where this goes. So this is the same example in interval notation. Or the same answer, sorry. So we've got set builder notation and interval notation. And they both say the same thing. It's just two ways of saying the same thing. Here's set builder notation, here's interval notation. They both say the same thing. So what about, let's try one like this. So 58 says negative 4d is less than or equal to 12. Okay, well, in this case, if we wanted to get d by itself, we're going to have to divide by a negative 4, right? So that cancels, and we get D. Now look what we did. We divided by a negative. If we divide by a negative, we have to reverse this sign. So since we did divide by a negative, we have to say greater than or equal to -3. 12 divided by -4 gives us -3. So with set builder notation, we just fancy this up a little, right? D such that D is greater than or equal to -3. Right, and that is set builder notation. Interval notation, well, you could do the same sort of thing again. It looks like it's pointing to the right, like this symbol looks kind of like an arrow pointing to the right. We've also got the equals to part. So we know far to the right is infinity. Or you could just think we want all the numbers greater than or equal to -3. Well, 5 is greater, 1,000,000 is greater. So with interval notation, you start with -3, you go to infinity. Infinities always get parentheses. And now -3, because it's greater than or equal to, right, greater than or equal to, we don't get a parenthesis, we get a bracket. Okay. And then one sort of like that. So I want to be able to make sure we can go in the other direction too. I want to make sure you guys have seen everything you're going to see for the most part. Number 56 is very similar. 56 says 4D is less than or equal to 12. So for this one, if we want to solve this, it's kind of a easy one. We can say, okay, we need to divide by a 4. So I divide, okay, I'm dividing. Do I need to reverse the direction? Nope, right? It's not dividing that does it. It's dividing by a negative. So since I divided by a positive, I don't reverse the direction, and we get this. So set builder notation, pretty easy, right? We just make it a little pretty. Put in these fancy braces. And we have D such that D is less than or equal to 3. Now with interval notation, we want all the numbers less than or equal to 3. Well, 2 is, 1 is, a quarter is, 0. All the negatives are less than or equal to 3, right? Because 3 is positive. And it almost looks like an arrow pointing to the left. The far left on the number line is negative infinity. Right? So we would go negative infinity, comma 3. Infinities always get parentheses. And this says less than or equal to 3, so we don't get a parenthesis on the 3, we get a bracket. Okay, so with this notation, it makes a difference if you reverse these. If I reverse these, it's the wrong answer because it's the notation says start here and go to here and include every number in between here. So the reason these mean the same is this says start at infinity and start going up until you hit 3 and include 3. So every number in between these two is part of the solution, which is the same thing this is saying. Okay, so let's try this other one. We've got a compound inequality again. Remember, that just means there's 2 of them. So just like with an equation, we know that whatever we do to one side, we have to do to the other side. Well, what if there's 3, air quotes, sides? They're not really sides here, but think of it as 3 parts, right? So if you just use what you learned about equations, you'll have some intuition here. We basically know we probably need to get this a by itself, right? And probably whatever we do over here, we have to do the same thing here and here. And that's exactly right. So what you learn from solving equations can be used here. Even though these are not equations, they're handled very much the same way. So if we want to get this a by itself, we want to first deal with this -2. So what we want to do is the opposite of that. We're going to go +2. So if I add 2 here, I'm going to have to do it here and here, right? Whatever you do to one side, now I have to do to 3 sides. So this will cancel. You get negative 6 plus 2, which is negative 4, less than or equal to 4a, less than or equal to 14. Okay, so now what we need to do is get rid of this 4. This a is being multiplied by 4. So we do the opposite. We divide by 4. But of course, if I do it here, I have to do it here and here. So I'm dividing. Do I have to reverse direction? Nope, because I'm not dividing by negative. Okay, so right here, negative 4 divided by 4 is negative 1. So we have negative 1 less than or equal to a, less than or equal to. We don't want to leave it like 14 over 4 because we would feel terrible about that, right? 14 and 4 are both even, so we can divide them both by 2 and get 7/2. Or if you prefer, you could write that as 3.5 or 3.5. Any of those are fine. So to write this with set builder notation, we have a such that, and you just copy that down. And we put these fancy braces on it. So that is set builder notation. Interval notation, we just say, okay, what's the smallest number? This. What's the largest number? This. We want the smaller number on the left, so we have negative 1, 7/2, or 3.5 if you prefer. That's fine too. And because it's in both cases, we have an equal sign, right? A is greater than or equal to negative 1, and a is also less than or equal to 7/2. But the equal to part means we don't get a parenthesis, we get a bracket on both of these. So these say the same thing. This is using set builder notation. This is using interval notation. Then there's another question they'll ask occasionally, something like this. They're going to give us this inequality, and they'll say something like, is y equals 6 a solution? Well, you don't need to solve this. That's the hard way. The easy way is to do just like we did when we had a similar situation with an equation. Do the same thing. So to see if y equals 6 is a solution, we take this 6 and plug it in for y and just see if it works. So basically, take this 6 and we plug it in for y and see if it works. So we would have negative 3 times 6 minus 7 is greater than 5. Well, negative 3 times 6 is negative 18 minus 7 is greater than 5. You can already see it's not going to work because if I have negative 18, then I subtract 7, I'm getting more negative, right? Negative 25 greater than 5, and the answer is no, which means, is this a solution? No, it's not a solution. So to see if something is a solution, just plug it in. That's the easiest way. You don't need to actually solve it and then see if 6 is in the solution set. It's much easier just to plug it in. And the last kind of problem that we'll have to be able to do is to translate these English phrases into inequalities. So for this one, it says, Tasha's average test score, T, exceeded 90. So T is her average test score, and it exceeded means it was greater than 90. So for this one, we basically just have T is greater than 90. This is the inequality that is equivalent to this English statement. So that should get you started. Make sure you try them out, of course. Try the homework problems. And if you have any questions, just let me know.